AOPS number theory 10.37. The product of two numbers has accidentally been erased by a student. All that remains is shown here. The student only remembers that the product was larger than 4,000. Name the larger factor. So if it's like this, we put this as A, B, C, D, E, and F. So B must be 4 or 9 because 8B ends with a 2. So 8 times B over here ends with a 2. So B must be 4 or 9. And since the product is greater than 4,000, it means that B is 9 because if B is equal to 4, then it's probably too small to be 4,000. And 9 times 10a plus 7 over here, 9 times 10a plus 7 is 12 more than a multiple of 100 because over here it's 12 and then a f. So 98 is 40 more than a multiple of 100, so 9a has a units digit of 4. Over here 9a has a units digit of 4, so a is equal to 6. That's the only way to make 9a have a units digit of 4. And so then it's like this. So then C times 68 is at least 300 but less than 400 because over here it's 3DE, which is in the 300s. So C times 68 is at least 300 but less than 400. So 4 is less than 300 divided by 68, which is less than 5, which is less than 400 divided by 68, which is less than 6. That means C is equal to 5. So then if we try 68 times 95, everything is correct. So that means the second factor is 95. AOPS number theory 10.41. The cube of the 3-digit natural number A7b is 10853133. What is A plus B? The only cube that has units digit 3 is 7 to the power of 3. So that means 400 to the power of 3 is equal to 64 million, which is less than this number, which is less than 125 million, which is 500 to the power of 3, which means A is equal to 4 because it has to be less than 500, so it has to start with 400. So A plus B is equal to 4 plus 7, since this is 7, which is equal, since B is 7, because the only cube that has units digit 3 is 7 to the power of 3. So A plus B is 4 plus 7, which is 11. AOPS number theory 10.45. In how many number bases B does this have a units digit of 2? So since they use 3 over here, that means B is greater or equal to 4. So this thing is basically equal to 7 times 32 in base B because there's 7 of these added together. And 7 times 2 is equal to 14, so that's like the units digit. So if n times b ends in integer nb plus 2 is equal to 14, that means b is divisible by 12. So divisors of 12 greater than 3, since it has to be greater than 3, is 4, 6, and 12, and all of these 3 number bases satisfy it, so there's 3.